In the middle of the 19th century, an Augustinian monk named Gregor Mendel took up the question of biological inheritance with a series of experiments. Mendel had a naturally inquisitive mind and a profound love of nature. His scientific interests ranged from research on plants to meteorology and the theories of evolution. Working at a monastery in what is now the Czech Republic, Mendel started by crossbreeding different strains of garden peas, then observing the characteristics of their offspring. Why choose peas? He did it, he said, for the fun of the thing. Mendel noticed that when he crossed a round pea seed with a wrinkled one, the offspring were round, not a mix of the two characteristics as he had expected. Yet when he bred the round pea offspring, that's where the mix appeared, and the second generation had both round and wrinkled seeds. He continued to experiment, trying to understand what kind of biological mechanism would cause certain characteristics to disappear in the first generation, only to reappear in the second. Then one day, Mendel counted the number of peas in the second generation that had the wrinkled characteristic. Exactly 1/4 of the peas were wrinkled. What Mendel observed in his experiments were the biological phenomena we now refer to as dominance and segregation, only Mendel didn't know it yet. Still, his experiments produced a curious set of facts which, as he said, forced themselves upon my notice. You see, no matter how he crossbred the various strains of peas, the hidden characteristics showed up, but only in 1/4 of the second generation. For Mendel, here was the breakthrough. For the first time, he could demonstrate that the traits of successive generations were inherited in certain numerical ratios. In other words, there were fixed laws of nature that governed heredity. With this insight, Mendel made the first great discovery in the science of genetics. Each inherited characteristic must be decided by a pair of what he called factors. Each parent, he said, contributes one factor for each characteristic. Certain factors are dominant and others recessive, depending on the combination of the factors the offspring inherits. Mendel's factors are called genes. The term Mendelian trait is used to describe a characteristic caused by a single gene that sometimes reappears in 1/4 of the offspring. That characteristic can be innocuous, such as freckles or the ability to curl your tongue. But it also can lead to serious illnesses like cystic fibrosis or Tay-Sachs disease. Imagine all that from one man's work with the humble pea.
Okay. All right, so we have this awesome interactive thing that we're going to do to explore how traits are passed from grandparents to parents to offspring. Okay, so I've made my own copy. And when you go into this activity, I don't want anybody going into it yet. But when you go into this activity, the first thing you're going to do is you're going to put your number, underscore, your name, first and last, and then another underscore, okay? Then the next thing that you're going to do is you're going to zoom in just a little. Well, that might have been too much. So we're going to zoom out just a little. Okay, so it says take 12 traits from grandfather A and 12 traits from grandmother A and give them to the mother ginger person. So these little circles are locked in. They're not going to change their shape. You just have to grab a bunch of them. So that's 3, 4. While I'm doing this, it's a good time to zoom in. You're going to have to zoom out for the directions, but when you're dealing with the manipulatives, you want to zoom in at 100%. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then I'm going to take these and I'm going to see if I can't slide them over just a little bit. And then I'm going to make sure that they're ungrouped. Group, ungroup. Click on one. Yep, we're good to go. Okay, then I'm going to take 12 from the grandmother. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm going to stop and I'm going to let you do those 3 things. The first thing that you're going to do is click on that blue this blue link right here. And when you click on it, you're going to rename it, making sure that you put your number and your name. And then I want you to zoom in at 100%. And I want you to take 12 from grandfather A and 12 from grandmother A. And then I want you to grab 12 from grandfather B and give it to father, and grandmother B and give it to father. And I want you to raise your golden hand to let me know that you have done so. Thank you, Addison. So mother should have 12 red and 12 brown. Father should have 12 yellow and 12 green. And we're going to label mom with 3 red and 3 brown. And we're going to label dad with 3 yellow and 3 green. Why 3? Because they have to have some to give away. Thank you, Kylie. Come on, guys, let's get going. Raise your golden hand when your mother and your father are set up and ready to go. Thank you, Chloe. Thank you, Kylie. Thank you, Deeksha. Thank you, Jordan. Thank you, Addie. Let's go, guys. Don't forget to raise your hand. All right, so we've done step 1 and 2 together. You guys need to hurry up. Come on, let's go. Thank you, McKenna. Come on, Bryson, let's go. Let's get those dots moved. Let's go, Jay. Let's go, Julian, Maitali, and Lily. Okay, so what you're going to do is you're going to open up your spinner in a separate tab. So you're going to double click on that spinner or click on the link. And then you're going to change your wheel size by hitting the drop down button and choosing 2 numbers. So we're only going to go between 1 and 2. So it says use the spinner and set the wheel size for 2 numbers. If you spin the number 1, it's going to be a red trait. If you spin the number 2, it's going to be a brown trait. It says spin the wheel 3 times and move the right color marker from Mother to Mary. So I'm going to come over here and I'm going to spin the wheel once by hitting the button that says spin. And I got the number 2. The number 2 is a brown trait. So I'm going to grab a brown, well, what just happened? I'm going to grab a brown trait and I'm going to move it to Mary. Okay. Then I'm going to spin again. For my second spin, I got a brown trait again. So I'm going to move a brown trait from Mother to Mary. And then I'm going to go for my third spin. Hit spin. I got brown again. What are the odds? So I'm going to move another brown trait from Mother to Mary. Okay. Then it says keep the spinner's wheel size at 2. Spin the wheel 3 times and move the right color marker from Father to Mary. So I'm going to spin it again. And I got a 1 this time. And it says 1 is yellow. So I'm going to move a yellow trait to Mary. There we go. Okay, then I'm going to spin again. And I'm going to move another trait. What was that? That was a number 1. Ugh, it gets stuck on numbers, doesn't it? All right, now I'm going to spin it again. Come on. Let's get something different. Okay, So now Mary has 3 yellow traits from her father and 3 brown traits from her mother. So now I'm going to label her as brown, 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 yellow, yellow, yellow. Okay? Then you repeat those directions for the rest of the offspring, George, Elizabeth, and Carl. No one leaves the site. Everybody works on their own paper, okay?
Miss Knupp, where is that?
It's on today's science lesson.
Okay.
Excuse me, can I mention something?
Yes, Matthew.
Since you got green and brown 3 times, I'm guessing green and brown are the dominant factors. Because you got them 3 times.
No, they're just the 2 traits. We're not talking about dominant right now. We're just looking at how the genes get passed down. So we're no longer looking at dominant or recessive right now. We're just focused on how Mary gets traits from her mother and Mary gets traits from her father. Okay? Tomorrow's lesson, is it tomorrow's lesson? No. Monday's lesson, then we're going to take the dominant and recessive and the passing down, and we're going to put them together, and we get to create a monster. Okay? But right now, focus on today's lesson. We're just looking at how traits are passed down from grandparent to parent to child.
Miss Knupp.
Yes.
So for the mother and father, so each of them they're going to get so for example, mother is giving 3 to Mary, like you said, brown, right? So
Yep.
you have to spin it 3 times for.
Yes. 3 different times. That's important.
So all of them
That's important.
to Mary, George, Elizabeth, and Carl.
Yep. Because Mary, if you follow the directions correctly, you're going to see something about Mary, George, and Elizabeth, and Carl.
Okay.
And that's the whole purpose of this lesson. So make sure you follow those directions. You have to spin for each color.
Okay.
Or spin for traits from each parent.
Okay. Thank you.
Okay? So now I'm doing my George. You guys may be somewhere else. All right, George gets the number 2 from his mother, which is brown. Come on. Oh. Come on. Yes. First red. Red. Oh, that's right. Okay, so 2 is green. Oh yeah. It's your birthday. The top 3 would be from the mother, and the bottom 3 are from the father. And yours are going to be different than mine.
Wait, how do we know what the label for like BBYYY? Like BBYY, for example.
B is for brown, Y is for yellow, G is for green.
Oh, okay. So we just do the starting of the color.
Right, the first letter of the color, yep. And so this is actually the second one that I've done. So you can tell a big difference between the first time and the second time. You can see how random it is. Okay? So we can see that Mary has no red traits and no green traits. We can see that George has more brown and green traits than anybody else. We can see that Elizabeth and Carl both have equal red traits and equal yellow traits. In fact, Elizabeth and Carl have the same exact traits, the same mixture of traits. Whereas George and Mary are very different from Elizabeth and Carl. If you're looking at my example. So I want you to think about that. You're answering the questions that follow on the next sheet. It says, then answer the questions on slide 2 based on your results. So you're going to go into slide 2 and you're going to double click inside the box. And you should see that the box lights up and you have a cursor. And the question is, would Mary, George, Elizabeth, and Carl look identical or have the same traits as their parents? That's important. Have the same traits as their parents. So let's go back and let's look. Will they all have the same traits as their parents? Don't call out. Let's look at the language of the question. Would Mary, George, Elizabeth, and Carl look identical? That means exactly the same as their parents. And so you're going to go in and you're going to type up your answer. I'm not typing up my answer because then everybody will just give me the same thing I give you. And that's not what I want. I want to know what your thinking is. Then you click the box 2. Did all 4 children inherit exactly the same traits? Or is there some variation? Variation is just a fancy word for differences. And so you're going to type up using the race strategy. So what would your question stem look like? You might type in yes or no, comma, name out the children, Mary, George, Elizabeth, and Carl. Look. And there's your answer. And then you may do your yes or no. all 4 children, and you may did or didn't inherit exactly the same traits. For example, and then use information from your sheet to explain your answer. How many of the 4 children inherited a trait from each one of the grandparents?
Wait, are we allowed to leave or no? We're supposed to stay.
No.
Okay, let's make sure.
And is there a child that inherited a particular trait? If so, which color was it? Or didn't inherit? So so-and-so, so-and-so, and so-and-so didn't blah, blah, blah. Okay? Just to kind of model what your sentences should look like. And make sure you spell the kids' names right. All right, I'm gonna set the timer for about, let's see, Addison, how much time do you think you need to finish? Oh, Addison's not here. Lily, how much time do you think you need to finish? Lily.
Not very long?
So maybe 5 minutes, would that be enough?
No.
Would that be too much?
No, it'd be too little.
Okay, so 8 minutes? Or you need 10 minutes?
Probably 10.
Okay. Let's set the timer for 10 minutes. Timer? Okay, so let's look at this. It says, would Mary, George, Elizabeth, Carl, and Carl look identical or have the same traits as their parents? When we look at the traits they have, does anybody have just red and brown? Ira, does anybody have just red and brown traits?
No.
Right. Okay. Does anybody have just yellow and green traits? Deeksha.
No.
Right. So none of the children will look exactly like their parents. Okay? And that should have been the conclusion that you came to. All right, it said, did all 4 children inherit exactly the same traits, or is there some variation? So let's go back and look at that. Did all 4 children, did they all inherit the same? Or is there some variation? McKenna?
There's some variation.
Right. There are 2 children who gained the same exact traits, and there are 2 children who gained a variation of traits. Okay, so Carl and Elizabeth randomly got the same exact traits. However, Mary and George vary vastly. You know, George is closer to what Elizabeth and Carl got, and Mary, bless her heart, she's like me. She's the odd one out in the family. Okay? All right. Then the next question is, how many of the 4 children inherited a trait from each one of the grandparents? So in other words, if they inherited a trait from each one of the grandparents, they would have a red, a brown, a yellow, and a green. How many of the children have those 4 colors? Diksha.
All 3 of the children, George, Elizabeth, and Carl.
Right. If you're looking at mine, what about yours?
In mine, every Mary, George, Elizabeth, and Carl got different, all 4 kinds of traits.
All 4 colors. Okay. All right. Did anybody have more than one that didn't get all 4 colors? So Diksha, put your hand down. Anybody who had more than one child come out like poor Mary and only got traits from 2 of her grandparents? Anybody? Or 3? Huh. Okay. I guess I'm the only one that got that weird roll, and it was weird for sure. Okay. And then the final question is there a child that didn't inherit a particular trait? If so, which color was it? So for mine, I would answer Mary didn't inherit a red trait from her grandfather or a green trait from her grandmother. So she missed out on 2 traits. And I could say, while everybody else got at least one trait from each grandparent. Okay? Awesome. So the good thing about this is you now have your classwork done, and all you have to do is hit submit. Okay? And another thing is, if you want to go back into this assignment and do it again and play around with it, you can, because there's an unlimited number of copies that you can make. But go ahead and submit today's work so you don't have to worry about it. And then, well, it's time for writing. So I'm going to stop recording for science.